Okay, so we're continuing with the homework task 9 problems that have to do with trigonometric functions and identities. And we're doing, we're trying to reduce trigonometric functions. That's what we're doing in these sets of exercises. So now we're going to do problem 14. Okay. So 14. So problem 14 says, I've got them written down here with my writing, so if I don't write anything correctly, let me know. It's tangent of x plus cotangent of x divided by cosecant of x, right? And again, what we're trying to do is simplify these. Ideally, simplify them to have just one trigonometric function, okay? So remember, in these exercises, what I would recommend for all of you guys, I'm gonna be doing them here in the whiteboard, but the recommendation is for you guys to have your notes and try to do them as well, okay? And the cool thing about last session that I really liked is that, again, there's many approaches we can have to solving the same exercise. So I'm gonna do it one way, but if any of you has another idea, say, well, what if we do this? We can also check it that way. And any solution that follows the correct procedure would be correct, okay? And so what I'm gonna do here for this one is that I'm gonna turn everything into sine and cosine. I'm gonna turn everything into sine and cosine, try to work something out. And so tangent is gonna be sine of x divided by cosine of x. Cotangent is cosine of x divided by sine of x. And cosecant is 1 divided by sine of x, okay? And so always when we have fractions, we're gonna try to join the fractions, okay? And so in the case of the numerator, I'm going to grab a common denominator, which is going to be cosine multiplied by sine. Cosine multiplied by sine divided by cosine is sine multiplied by sine is sine squared. Cosine multiplied by sine divided by sine is cosine multiplied by cosine is cosine squared. If anybody has a question, let me know.
I didn't understand why.
Okay, so what we're doing, we're joining these two. We're joining these two. I'm sorry, when we have a fraction, what we do is we're going to grab the common denominator, and the common denominator is going to be the product of the denominator. So the common denominator is going to be these two. Okay. So the common denominator is cosine of x multiplied by sine of x, right? Mm-hmm. And so then we go with the first one. We take this common denominator and divide it by this value here. So if I divide cosine of x by sine of x, I get sine of x. Oh, okay. And I'm going to multiply this by the numerator. So I'm going to get sine of x. Then I'm going to grab this one. Cosine of x, sine of x divided by sine of x. These eliminate. Cosine multiplied by the numerator, this is squared, plus cosine squared of x. And that gives me the new fraction. So you always take the common denominator, and if you remember also, it's you multiply the two things in the denominator, and then you multiply cross by. Okay, so it would have been the same to say that you multiply sine by sine and cosine by sine and join these two together. So always when we have a fraction, we're going to try to join that fraction into one by doing that, okay? And then what's next here, we're going to do the tortilla law. Multiply this by this, multiply this by this. Continue up here. And that would give us, oh, and we also know that sine squared of x plus cosine squared of x is equal to 1. That's the Pythagorean. So that means that I've got, in the end, I've got sine of x divided by cosine of x multiplying sine of x. The sine of x is going to be eliminated. And you have 1 divided by cosine of x. And 1 divided by cosine is second. Whoops, I was gonna write something else there. It's not a trigonometric function.
Why did it convert to a 1?
Remember that we've got three Pythagorean identities. So remember that the basic one is sine squared plus cosine squared is always going to be equal to 1.
Okay.
Okay, so the sine squared plus cosine squared, this is equal to 1. 1 multiplied by sine is sine, and cosine multiplied by sine multiplied by 1 is cosine divided by sine.
And it's because you cancel the sign, so
Mhm.
I didn't understand why they still call me 1 at that's all.
Mhm. When you cancel these out, you're left with a 1 on the numerator. Yes.
I'm so confused how you have the sine x over cosine of x and sine of x. I think find the sine squared plus cosine squared of x equals to 1.
Okay, let's look at rows. Row 1, 2, 3, 4, or 5. Which
I'm so confused how you got from 2 to 3.
from 2 to 3? Okay. Okay, so okay, from 2 to 3. Okay, so okay, so we're okay up to this point here, right? We join these two, and this is equal to 1, right? And then we do the tortilla law. So the ones on the opposing sides are going to multiply. So actually, here you have a 1. So 1 multiplied by sine is sine. And then cosine sine multiplied by 1 is cosine sine. It's in the numerator. So remember that the tortilla law says that it's not correct that I call it. I think it's politically correct. It's not appropriation, but it's politically incorrect that I call it tortilla law. When you've got the tortilla law, basically says that this. So here you have a fraction divided by a fraction. The resulting fraction is going to be A multiplied by D and B multiplied by C. I was going to have a fraction divided by a fraction. The two extremes go on top, the two middles go on the bottom. Take a screenshot of this. Okay, questions with this one? Over at home, how are you guys doing? Questions? You guys still there and awake?
I'm doing fine.
Good, perfect. Anna, are you there?
Yes.
Some quick questions, Anna. Turn on your camera, please. Okay, so three quick questions. And so we're seeing the trigonometric functions here. So question number 1, what are you studying? It's very important for the unmute, for things to be unmuted.
Oh, I forgot.
What are you studying on?
Industrial Engineering Global Program at Cetis University.
Wow, and that must be really difficult. You must be really smart. Good job. Thank you, Anna. You may turn off your camera if you wish. That's probably the most important part of the course, you guys. Actually, in the symposium, I don't know if you noticed in the panel. Well, I was seeing it because I was I'm sorry, I was seeing it because I was in the like sort of the waiting room or something like that. So I was seeing the auditorium, and the MCs in the auditorium were actually interviewing students, and they were asking, what are you studying? And one student said mechatronics engineering, and the interviewer said, oh, that must be really difficult. And I actually had one of my mechanical engineering students that was in the room, and I was texting him that we did this same exercise with them. And I was texting him that he should answer that, but he got shy. The what?
Y ya when we were playing, sin trascendentes dijeron, they asked like why is not subject for the students of the first semester, and we had already said chemistry, math fundamentals, product, and we were like, we had no idea because for us, gestión and introducción is not hard.
Yeah.
So we're like, what can we say? And I said like, inglés. They were like, no sé si inglés. You, we go program.
Actually, the toughest subject. Everybody says the toughest subject in first semester is programming. That's the most difficult one, but you don't. That's odd with you guys. You don't seem to be very as stressed with programming as students usually are. But that might be a good thing. That might be a good thing. Okay, questions with this one, 14. No, let's jump over to the next one. Okay, we'll get done today. 16. So we've got sine of x, multiplying the tangent of x. Times the cosecant square of x minus the sine of x multiplied by the tangent of x. So there's many approaches we could do here. We could substitute some Pythagorean one there. We could also turn these tangents into sine and cosine. Let's see what happens if we do that. And why am I trying to turn the tangents into sine and cosine? Try to generate some sort of sine and cosine squared that might be useful. Anytime I can generate a Pythagorean identity, it's useful. And cosecant is 1 divided by sine squared. Here we've got sine of x multiplied by sine of x and cosine. So if we turn everything into sine and cosine, it's a sure way to go because something's going to happen. It might be lengthier than other paths, but it's a sure way to go.
You cannot subtract.
We're going to try to subtract whenever we've got something that's common. Oh, there's another way of doing this more simpler, much more simpler than what I'm doing. I'm going to do it in a moment. And I think Joel already identified it. I'm gonna call this one path number 1. And I'm gonna finish this up. And if somebody's identified the second way of doing it, then when I've finished, let me know and we'll do that as well. So here, if I multiply these two, I'm gonna get sine squared of x divided by cosine of x. And I've got 1 divided by sine squared of x. So these two, well, let me write everything down. And I'm gonna get sine squared of x here divided by cosine of x. It's gonna happen here. These two are gonna eliminate. And I'm gonna be left with 1 divided by cosine of x minus sine squared of x divided by cosine of x. And we've got a common denominator here, so I can actually join those two, and I would get 1 minus sine of x squared divided by cosine of x. We know that,
Did you,
yes,
like if it's in binary matrix, right?
you got it? And here we know that if sine squared of x plus cosine squared of x equals 1, then cosine squared of x is equal to 1 minus sine squared of x. So we can substitute that here. This would be equal to cosine squared of x. So this would give us cosine squared of x divided by cosine. The square is going to eliminate with the cosine, and we're going to be left with just cosine of x. So that's one way of doing it. What's another thing that we could do instead of doing that? I'm not necessarily saying it's going to be shorter. I'm just saying it's could be another way.
Using the identity of cosine,
Which one?
CSE. Alright, cosine, right?
But which identity?
The second square plus 1.
We notice that there's a cosecant squared there, so maybe we could use that identity there. But before we do that, is there something we can factor there?
There's the sine, but tangent, you can use the same.
Yeah, sine x tangent x is here and is here, so we can factor that first. And if I factor that, I'm going to be left with cosecant squared of x minus 1. And the other cosecant squared minus 1 is equal to, but this is also cotangent. This is also a Pythagorean. So this here derives from 1 plus cotangent squared of x is equal to cosecant squared of x. So this means that this would mean that cotangent squared of x is equal to cosecant squared of x minus 1. So this means that this here is equal to cotangent squared of x. That means that we would have sine of x multiplied by tangent of x multiplied by cotangent squared of x. Okay. And that's one simplification. That's reducing a lot of things there. And the next thing we can do from here is that we can turn everything into well, we could do this as well, sine of x multiplying tangent of x. We know that cotangent is 1 divided by tangent. So this is the same as having 1 divided by tangent squared of x. This is going to eliminate the tangent and the square. And we're going to be left with sine of x divided by tangent of x. And from here, we can turn everything into sine and cosine. So this is going to be equal to sine of x divided by sine of x divided by cosine of x. This is going to make the sines eliminate. And I'm going to be left with 1 divided by cosine. I'm sorry. The sines are going to eliminate. Do it this way. This is the same as having sine of x divided by 1 divided by sine of x divided by cosine of x. And in this case, if we use the tortilla law, we're going to get sine of x multiplied by cosine of x divided by sine of x, and the sine is going to eliminate. And we'll be left with cosine of x, which is exactly the same thing we had over here. So both paths or procedures would be correct. Actually, if also, I don't know if that was where you were going, but also if we substituted directly the cosecant squared of x for 1 plus cotangent squared of x and did all the multiplications, we would also get to the same result. So there's more than one way. I'm sorry, there's more than one path to getting to the same result. Yes.
How did you get the cosecant?
How did I get to the cotangent? Here?
Yeah.
Okay, so remember that there's I'm gonna write it up again here. There's more than one, there's 3 Pythagorean identities. So there's one Pythagorean identity that says that 1 plus cotangent squared of x is equal to cosecant squared of x. Okay. So if I send this one over here, I'm going to get that cotangent squared of x equals cosecant squared of x minus 1, which is exactly what we have here. Okay, so we substitute. So whenever you see sine, cosine, second cosecant, tangent, or cotangent elevated to the square, it's kind of an indication that you can use any of the Pythagorean identities to manipulate. Okay.
Oh, and the minus 1 came from the sine x, tangent x.
Uh-huh.
Okay.
Take a screenshot of this. Okay, questions with this one before we go to the next one? Next one's a big one. I'm gonna clear this. Remember again, all of these procedures are in the PowerPoint of what's called workshop number 9, okay? I've updated them up until problem number 12. I'm gonna upload the ones we did today later today, so those are going to be available there, okay? So I'm gonna clear this. Let's see. Let's look at number 18. So we've got 18 here. So 18 says, so this looks like a big one. It says sine squared of x times cosine of x plus cosine to the 3 of x minus cosine of x plus sine of x, and everything's divided by cosine. So we want to just want to verify that it's correct. Sine squared cosine, cosine to the 3, cosine plus. Okay. So what did we do there? That's a lot of stuff there. I think there's more than one way to do this. So any suggestions as to how to start?
Can we separate? So let's say like sine to, well,
We can divide it. Just
Hey, we reduce the
sine
cosine,
x.
cube with the cosine minus.
Okay, so many things were said. Let's analyze each of them. So what I heard is if we can reduce it and eliminate some things there. So let's go through each one. So Joel, you said something first.
So divide the cosine to sine plus cosine to the square plus sine.
We've got a cosine there in the denominator. Maybe we could divide by that one and try to reduce that. That's one thing. Daniel, you said something as well?
yes, you said like, how we have like sine squared of x times cosine of x divided by cosine of x, and then like plus like have 3 fractions and work on each of them individually, or we cannot do that.
Divide them, yes, which is what Hoyle is saying as well. So we're basically going to divide by cosine each of the elements. So yes, we can do that. That's correct. And then Andres, you were asking something as well.
If we could do the cosine cube with the minus cosine.
No, we can't do that because remember our rule when we're adding or subtracting, we can only add or subtract things that are the same. And when we say the same, they have to be exactly the same. So cosine and cosine are the same, but cosine and cosine to the 3 are different. But we can do a division here. Let's see if that helps us out in some way. So what we're going to do, we're going to separate these. So I've got sine squared of x, cosine of x, divided by cosine of x plus cosine to the 3 of x divided by cosine minus cosine of x divided by cosine plus sine of x divided by cosine. And let's see what happens here. So this is going to eliminate with this. The 3 is going to eliminate with the cosine. These 2 are going to eliminate, and thus is going to be left the same. So this is going to give us sine to the square of x plus cosine to the square of x minus 1 plus, well, this would be tangent. Tangent of x. Okay, so what can we do there? Any suggestions over at home? People at home. Anna, Ayman.
I have a question.
Yes, go ahead.
What's up with the number 1? I got lost and somehow, or is that a minus after the cosine squared?
Cosine.
Is it about the Pythagorean function? Is that a Pythagorean function, or why is it like cosine square x minus 1 plus tangent?
Okay, so what we're doing here, Marco. So was this first step understood?
Yes, you're just canceling out and simplifying the.
No. Before the red. Was it understood that we separated it, divided?
Yeah,
Okay.
you separate it in order to.
Okay,
simplify.
so if we grab the first one, Marco, the cosine is eliminated and we're left with sine squared, right?
Yes.
If we grab the second one, it's cosine to the 3 divided by cosine. The cosine is eliminated and the 3 turns into a 2. So we get this one, right? And what happens with the third element? It's cosine divided by cosine.
Oh, okay.
So we get the minus, and then the sine divided by the cosine, we get the tangent.
Okay. I get it now.
And what can we do there, Marco? Once we have that, and here in step 2, what could we do here in step 2?
We could, let me pull out the notes I have with the rest of the Pythagorean things. We can sine square. The sine square x plus cosine square x, that's a function, right? A Pythagorean function, I think.
Yes, correct. That's the way to go. What is that equal to?
It's equal to, give me a second. 1.
This is equal to 1. Correct. So all of this is equal to 1. So that kind of simplifies things a lot because we're going to have 1 minus 1 plus tangent of x. And the 1s are going to cancel out and we're going to be left with tangent of x. Okay. It's definitely different than the way I solved it here, but I mean, we get to the same thing in the end. So questions with this one? Okay, let me take a screenshot of this. Yes,
You did it in another way, teacher?
I did it in another way. I think it's a bit more long. Let's look at that one as well. So I'm going to call this one again path 1. Let's assume that I want to complicate things a little bit more. But again, if you're doing these in the exam or in the homework task, I'm not going to grade how complicated your solution is as long as you follow the identities, okay? So another way of doing it is I'm going to take advantage of the Pythagorean identity and I'm going to substitute. So we know that sine squared of x plus cosine squared of x equals 1. This means that sine squared of x is equal to 1 minus cosine squared of x. So I'm going to substitute that in the first part of the function. And so I'm going to get 1 minus cosine squared of x multiplying by cosine of x plus cosine to the 3 of x minus cosine of x plus sine of x. And everything is divided by cosine. If I multiply here, I'm going to get cosine of x minus cosine to the 3 of x plus cosine to the 3 of x minus cosine of x plus sine of x. And everything is divided by cosine. And what's going to happen here is that because of this multiplication, the cosine to the 3 is going to be eliminated with the cosine of the 3. The cosine is going to be eliminated with the cosine because they have different signs. And I'm going to be left with sine of x divided by cosine of x. And this is tangent. Okay. That would be another way of doing it. So again, it's like unraveling the chain as long as you have the or use the identities correctly, you can get to the same solution. Okay, so back to math. Let's try to do number 20 now. Okay, so any suggestions how we could address that? So what can we do there?
Well, we can try to make everything time improvement.
Let's try that. We don't have any Pythagorean or anything elevated to the square there that might be helpful, so let's try doing that. So we've got sine of x, and over here we're going to have sine of x divided by cosine of x. And cosecant is 1 divided by sine of x plus sine of x divided by 1 divided by second, it's cosine of x. So here we're going to assume that these have a 1 under them, and let's do the tortilla law for these two. This is going to be sine squared of x, and this is also going to multiply, so it's actually going to be sine to the 3 divided by cosine of x plus this is going to be sine of x multiplied by cosine of x.
So we multiply both of those signs on top, so we sine cube.
So basically what we're doing is sine multiplied by sine is sine squared, and then multiplied by the 1 on the bottom is sine to the 3. And here, well, we've got a fraction and another element here that isn't a fraction. So let's join those two with the common denominator of cosine. So we're going to have sine to the 3 of x plus sine of x. And cosine divided by 1 is cosine times cosine is cosine squared of x. Once we've got that, we can, I'm gonna bring this over here.
Sure, what is it, square cosine?
Oh, okay, so from here, we're gonna join these two, and the common denominator of it is gonna be cosine. So it's gonna be cosine divided by cosine is 1 multiplied by sine to the 3, it's sine to the 3. And here, imagine that we have a 1. Okay. So cosine of x divided by 1 is cosine, multiplying this here is gonna, the cosine is gonna turn square. Okay. Bring it over here. And so I can factor the sine. And if I factor the sine, I'm going to have sine to the squared of x plus cosine to the square of x divided by cosine. The sine square plus cosine squared of x, this is a 1. And we are left with sine divided by cosine, which is tangent. So questions with this one? Do a quick screen grab here. So let's look at number 22. And here we've got sine squared of x minus 1 multiplying cotangent squared of x plus 1. Okay, so what could we do? What could we do there? Any suggestions?
Sine square of x, you can turn that one into.
So we've
You
got
can
it.
go to cosine square, right?
So we've got it. We can use the Pythagorean. So we've got sine squared of x plus cosine squared of x equals 1.
The cotangent is also cosecant square.
And here we've got cotangent squared of x plus 1 equals, this one is the cosecant squared of x. But here we've got sine squared of x minus 1. Okay, so
This minus.
so if I say, or if we say cosecant squared of x is equal to 1 minus sine squared of x. But here it's sine squared of x minus 1, which is actually minus cosine squared of x would be minus 1 minus sine squared of x, which is equal to sine squared of x minus 1. So this one here is cosecant squared of x. And this one's here is minus cosine squared of x. So that would mean that what we have is minus cosine squared of x multiplied by cosine squared of x. We know that cosecant is equal to 1 divided by sine. And so we've got cosine squared of x divided by sine squared of x. This is going to give us minus cotangent squared of x. And we can leave it like that. That would be as simplified as we could have it.
Ya, yo,
A ver, vamos a ver, venga.
Teacher,
Yes.
why do we get there? Contingent.
So from here, this would be equal to minus cosine squared of x divided by sine squared of x. And so cosine divided by sine would be cotangent,
Okay.
or 1 divided by tangent.
Okay.
We're going to do 24 here on this. So for 24, we've got 1 plus sine of x. Okay, 24. I'm going to do those on another slide. Before that, questions with this one. The next set of problems are a bit different from these, or they're actually asking us to do something a bit different. So in the next set of problems, problems 24 onward, we're going to be given a mathematical expression or equation, actually, like this one, for example, 1 plus sine of x divided by cotangent of x is equal to, oh, cosine. Cosine is equal to secant of x plus tangent of x. In these problems, we're going to have two expressions that are not the same, but are equivalent. So we've got one on the right and one on the left. What we need to do is demonstrate that they're equivalent. And there's actually three ways of doing this, or three approaches. One is we work on the expression that's on the left and work on it until it looks like the expression that's on the right. And that means that it's demonstrated. The other is the other way around. We work on the expression on the right until it looks like the expression on the left. And the third way is that we can try to join both expressions and try to, in the end, get to two things that are equivalent. What we're trying to get to is what's on the left is equal to what's on the right, and it's exactly the same. So I'm going to do it using the first two ways. So we have to demonstrate that 1 plus sine divided by cosine is the same as secant plus tangent. So I'm going to do it first through here. I'm going to call this path number 1. And I'm going to work on the one that's on the left. So what I'm going to do is I'm going to separate this into 1 divided by cosine plus sine divided by cosine. I'm just separating this into each of the fractions. And I get that 1 divided by cosine is secant of x. And sine divided by cosine is tangent of x. So this is equal to this. Okay, so we've demonstrated that so this is one way of doing it. We grab the one of the sides and just work on it until we get the one that's on the left. We're trying to demonstrate that the expression is equivalent. We're not trying to solve the equation. That's the point. We're not trying to solve it. We're trying to demonstrate remember the concept of an identity. The concept of an identity is that we've got two things that look different, but are equivalent. And so we've got two things that look different and are equivalent. We're trying to demonstrate that these two are equivalent. The other path is grabbing this one here. This is path number 2.
It's just backwards, right?
That's exactly the same. Basically, what I'm going to say is that secant is 1 divided by cosine. Tangent is sine divided by cosine. If I join these two, I'm going to get cosine 1 plus sine of x, which is exactly what I had on the left. Okay. So either of these are valid. Okay. So again, these we're trying to demonstrate that what's on the left is the same as what's on the right. Again, it's practicing that the concept of an identity. Questions with this one? Well, when do the Spanish classes end? Do they end at the same time as the rest of the classes, or do they end before or after?
Well, I just read a backward that it says, este no es para informarles que la sesión del día de mañana, 18 de noviembre, empieza a las 1:15 con el objetivo de dar cierre a la asignatura.
So it is this week. I had the idea that they ended before Well, they didn't end at the same time as regular.
They ended before and they started like 2 weeks after. We started.
Yeah, it's a short, it's a more compact
And
course.
se me hizo claro. It's really hard. And
It's a lot of writing.
yes. And I'm not very good at it.
Yeah, that's usually one of the key issues we have sometimes in engineering, that we're not used to writing. And it is, I would recommend, it is something very important for you guys to develop, because it is a useful skill.
The problem I have is that I have it in my head because like I speak a lot, so imagining something is not that hard. But when I try to write it, I pongo mal los verbos, no pongo acentos, hay words, yo batallo.
Oh, so your problem is more the structure, not the writing itself.
I don't follow like none of the rules. I don't know how to determine if a word is esdrújula, grave, or I don't know how to.
Usually the problem that I see most students have when they're writing essays and all that is that, so if I tell somebody to write, oh, I need to activate the Trascendencias essays discussion forum, I forgot about that. We do that today. If I ask you to do a 2, 4, or 5-page essay, have a lot of trouble filling in the pages. And again, that's something that I recommend you guys work on. Okay. So we've got those two that we're trying to make this, we're trying to make demonstrate that those two are the same. So I'm going to first work on the left-hand side and see what happens. I'm going to separate this, and this is going to be equal to 1 divided by tangent. Plus 1. And 1 divided by tangent, I know that that's cotangent. Plus 1. And just remember that we've got the Pythagorean identities. So we know that 1 plus cotangent squared of x is equal to secant squared of x. No, it's cosecant, right? Let's get those mixed up.
You can change it for the 10 for the tangent and the tangent square of x plus 1 equals second square of x. Second.
Yeah, I'm sorry, I'm mixing them up. Let's be hungry. Sorry about that. So we're working with the tangent, not the cotangent. So the identity, the Pythagorean identity I was talking about is tangent squared of x plus 1 equals secant squared of x. So if we reorganize this, we're going to have that secant squared of x minus tangent squared of x equals 1. So the same way we eliminate the Pythagorean and say this expression is equal to 1, whenever I have a 1, I can turn it into the Pythagorean expression. So this 1 here is the same as having this. And so therefore, this is equal to cotangent of x. plus secant squared of x minus tangent squared of x, which is exactly what we had, which is exactly what we have on the right-hand side.
The ones, I can only convert them to Pythagorean identities. I cannot convert them to, like, let's say, sine over sine.
If it would be useful to do for some of the manipulations, yes, you can do that.
No.
If somehow that could help to join a fraction or to eliminate something, you could do that. Now, path number 2 would be to use this to work on this side. And that would be very similar. So we've got cotangent of x. We've already established that secant squared of x minus tangent squared of x. Let me do this, write this down, all of it. We've already established that tangent squared of x plus 1 is equal to secant squared of x, and this gives us that secant squared of x minus tangent squared of x equals 1. That would mean that this one is equal to 1. That would mean that cotangent of x plus 1. Cotangent is 1 divided by tangent plus 1. We join these two. Tangent of x, we have 1 plus tangent of x, which is exactly the same thing we had on the left. And so with either of these, we've demonstrated that the expressions are equivalent or that they are an identity.
So there's always going to be two solutions to these ones, right?
No, actually, something important here on this. What in all these problems, when I say path 1 and path 2, it means you can do either one.
Okay.
So basically what you're trying to do, the only thing you're trying to demonstrate is that what's on the left is the same as what's on the right. So if you do it the first way, you've demonstrated. If you do it the other way, you've demonstrated it as well. So it's basically to look at in which of the sides you think it's easier to work with. And any of them are correct. You don't have to do both.